Hey, everyone. Thanks for taking the time here today. It's great to meet all of you. My name is Chris Latimer. I'm one of the co-founders of Vectorize, but I've got a long history in tech before this. I was at a company you might have heard of called Google before this, where I was a product manager. I was really focused on building cloud services at scale there. And I was at a company called DataStax, who you might know from Apache Cassandra. And when ChatGPT hit, they became a vector database. And so I started to get really into unstructured data for AI when I was at DataStax. And I ended up doing a bunch of AI research with the team at Virginia Tech. And we published 3 papers now on different ways of improving the performance of retrieval strategies, with our most recent one being a topic I'm going to talk about today, which is what we call Hindsight, which is our AI memory system that goes along with the research that we publish. If you want to connect with me, you can send me a request on either LinkedIn or on X. I'm on both of those. I'm a little bit more active on LinkedIn. So excited to be here with all of you today. So thanks again for attending. So let me start off by saying, I think, RAG is dead. It seemed cool at first, and I'm gonna talk about more about exactly what I mean by this, and sort of maybe caveat a couple things about this. But let me before I get to that, let me talk about a little bit of the history of how we got here and why I think this is the case. So, at first, if we go back, a few years, all we really needed was the LLM. We all got that first access to ChatGPT. Most of us have a core memory that was formed where you realize all of a sudden you could ask ChatGPT to say, hey, go write me a blog post or a paper on this. And you were like, wow, that's amazing, until you read it. And then, maybe that got enthusiasm got dampened a little bit, although the models have gotten a lot better since then. But one of the things that became apparent pretty early on is that there's just too much missing knowledge inside of the LLM. LLMs get trained, and they don't get trained on your, thankfully, on your company's private data. And so we had these gaps in our knowledge that we had to figure out ways to work around. And so that led to us creating new techniques because we wanted our LLMs to increasingly automate more work, not just to do sort of like basic chatbot, but we wanted them to become more sophisticated. And so one of the techniques that we invented was retrieval augmented generation. And the way that most people approached RAG is that they would take a bunch of documents and they would chunk those documents up and they would stick them into a vector database. And you would build out some sort of conversational AI where your user would ask a question, you would find context that's similar to that question that the user asked, you'd pull it back, and then you pass that to your LLM. They would then generate a better response. And this was very compelling at first because you could essentially get your LLM to generate responses about topics it wasn't actually trained on, which was a cool feature. Now, it's a cool feature that whose novelty wore off very quickly for anybody who's gone down the path with RAG. It works really well for some things. If I have a bunch of documents and all I want to do is find the relevant context within that set of documents. So for example, all of the documentation for our product at Vectorize, if I'm going to look for things like, hey, what source connectors do you support? RAG is pretty good at that. I can go find those. I'll probably find a page about source connectors, and I'll pull back the relevant information. Now, the problem is when you go and you build an AI application for, say, like business partners that you work with for, interdepartmental use cases, users aren't trained to know what a vector database is good at retrieving and what it's bad at retrieving. So I've heard so many times over the years, people come to me and say, hey, I loaded all of these documents into my system. I loaded all of these statements of work. I'm a contracting company. I loaded all these statements of work, and I asked how many SOWs do we have with Citibank, and it couldn't tell me the answer. And that's not surprising if you know how vector databases work, because it's not a semantic search question. It's not something that the vector databases are going to be very good at, and the thing that the real Achilles heel here is for a lot of applications, not every application, but for a lot of applications, the things that RAG is good at, going across like a few hundred pages of documents, you can actually now just stick those in the context window for these models that have bigger, like million token context window. You can easily fit all that in there. And so all of a sudden we have this trade-off between, do I want to build out this data infrastructure for that, or do I just want to stuff this stuff into the context window? And so, for those reasons, a lot of people have kind of become frustrated with RAG. And increasingly what we want to build aren't just chat applications. They're not just AI, conversational AIs. We want to build out agents that can actually figure out how to solve tasks independently. We want to start to approximate almost what an AI employee would be, where I can give it open-ended tasks, I can give it tools, it can figure out how to do jobs and tasks and eventually entire business functions. And in short, for us to do that, we need our agents to have agency. And so our data strategy is, needs to be a little bit more sophisticated. And what a lot of people have concluded is that RAG is not enough. And so when I say RAG is dead, what I really mean by that is the days where we could get by just taking a vector database and putting a bunch of documents in there, it's in the past. We need more sophisticated data strategies to do that. And that's going to be the focal point of the rest of my talk here today. So let me share some observations. Everything that I'm presenting here is based on my experience. We've built a lot of agents over the past couple years. And I will say that if you're building agents, you probably have run into all four of these problems. Starting off with inconsistency, probably one of the most frustrating things that an AI engineer runs into is that you'll build an agent, you'll give it a task, and it will solve it and you're happy. And then you ask it to do that same thing again, and all of a sudden it just decides to do something different and is unable to solve the task. And so we end up kind of getting into this prompt engineering loop where we keep trying to make better and better prompts. And that will help somewhat, but usually not enough that we're confident in production. Likewise, we have to deal with hallucinations. So, as you start putting in more context into your context window, you'll end up with an LLM that's confused, and it will start making up things about what it found in your context. And that's usually unpleasant for everybody, especially you as the AI engineer. And then as that context grows, we start to see this sort of context rot over the course of a conversation. The agent gets a little bit worse and a little bit worse and a little bit worse. And oftentimes when you give your agent really complex tasks and a bunch of tools, it will just get stuck. It'll start just doing weird stuff, making different tool calls for no apparent reason, things that you look at and kind of make you scratch your head. And so these are some of the problems that we want to solve. And the good news is that most of these agent problems, if you get down to the core, the root of the problem, they're really more memory problems. So things like inconsistency, our agent knew how to solve a problem one time. So why didn't it solve the problem, the next time? And the answer is because we don't really have these feedback loops built into our agents most of the time. And there's no way for the agent to look at what worked once and what didn't work the next time and figure out, well, what was it about those two things that I did differently that I should learn from? Likewise, from a hallucination perspective, a lot of this is really our kind of semantic memory. This is the things that, from humans, we think about this like, this is like the books on your bookshelf, right? It's like you don't memorize everything that you've ever read. Sometimes you go back to the reference material. And we end up with this cognitive overload. So, our context will get really big. You kind of overload what the model is capable. Even though the context windows are big enough, a lot of models are not capable of actually processing that data or interpreting that data correctly. So these are things that we have to think about. And a lot of these really go down to this idea of agent memory. Now, from a short-term memory perspective, there are common problems that we run into. So if you've built agents, you probably have been in this state before where you ask your agent to do something, it doesn't do exactly what you want, you go back to the prompt and you update that prompt. And over time, that prompt can start to get pretty long. It's not uncommon to see prompts that are pages and pages long of instructions. And it's almost like an archaeological dig through all the different things your agent has done wrong and the instructions that you're giving it to hopefully correct that. And so you start off with a long prompt, and then we often try to just inject more context into that window. And so we start to see, well, I didn't get what I wanted back from my vector database when I got the top 5 results. What if I get the top 20? What if I get the top 50? And now all of a sudden we're loading up that context window with a lot of things that are irrelevant so that we can hopefully find the needle in the haystack that we want. As conversation histories are getting longer, our context window is growing. And then things like MCP have really complicated this idea of tool calls, where the LLM now has a lot more tools that it can select from. And so the likelihood that it's going to make mistakes as it tries to make those tool calls goes up. Now our context window is filled up with unnecessary tool calls and tool outputs that our agent is trying to make sense of, or the LLM is trying to make sense of. And likewise, we still need these ideas of semantic memory. We still need our bookshelf. We need to go back to the source material. Now, the problem here is that different queries need different types of retrieval. And so there are things where plain old vector search is good, right? If I am building a AI assistant for my employees and I want them to be able to ask questions about our policies, and you say, hey, what's our sick leave policy? And my employee handbook has that, then vector is going to be a good option for that. It's going to pull that data back. Now, if I'm building out something like for my vendor management, and I want to know how many contracts we have that are going to be come up for renewal in the next 60 days, that's something where I probably want more of like a select star type, select count from contracts with expiration date is within a certain amount of time. Sorry, Saka, was that a question?
Yes, I got a question from Karuth. Can you give some examples along the way, long prompts, long context, etc.? What validation loop was there and how we know it did not work?
How would you know it didn't work?
Mm-hmm.
Yeah, I mean, usually it's fairly straightforward. Your agent just doesn't do what you want, right? Like you pass in a bunch of context into your context window, and your agent just isn't making use of it. These ideas of context rot are pretty common. They're usually not hard to identify when you start to see this stuff, right? And usually this is the type of thing where, like, if you've ever gone through the exercise of, hey, I'm going to go search the top, the top 5 results from my vector database, and then I move to the top 10, and then I move to the top 20, 50, 100, whatever it is. You've been in this case where all of a sudden you've got your context window is exploding. That's all costing you tokens too. Your LLM provider charges you by tokens. And so you start to see that you start to see the quality of responses go down. Users usually are not very shy, I would say, about telling you when they see those problems. So usually those are pretty self-evident. You don't need any sort of fancy evaluation to do that. And I'd say this is a harder problem where when we start to get into like our retrieval strategies, we have to think ahead a bit about the tools that the agent needs to be able to get the data that it wants. So sometimes we do just want sort of general search. And sometimes we want to create more specialized search functions for the LLM and for the agent to be able to retrieve things in a specific way. And that will be dictated by the nature of your data, right? So if you are working in finance and you have a lot of SEC filings, for example, you would want to create search functions here that would say, I need to search for just filings from a specific company. So you might want to have ticker symbol, or you might want to have things like the fiscal quarter or fiscal year, so that you can, if somebody asks a question like, how did Google's top line revenue grow from 2023 to 2024? I want to be able to search just the filings for 2023 and just the filings for 2024, pull those back and get an accurate answer. And so these sort of things where you want to be able to support those are going to lead you down the structured path. Graph is going to lead you into this world of kind of multi-hop. If you have a lot of interconnected data, especially interconnected relationships, a lot of times the examples you see from GraphRag or from Knowledge Graph, in my opinion, at least, get a little contrived. It's like, I don't know anybody who goes into their agent and says, who won the Oscar, for this movie, who co-starred with this other star, 10 years ago, right? A graph database is able to handle those type of relationships if you've extracted the entities correctly. And most people don't sort of query that way. But in a graph data structure, you can start to kind of walk the graph. And the idea is that you start to get the nuanced relationships between different entities that come together. And so all of these are to say that all of this is to illustrate not so much these individual techniques, but just the fact that if you are building out an agent in 2026, sad to say the days of you just populating a vector database are not going to cut it. And that led me down kind of my most recent path of research that we put this together with the team at Virginia Tech. And essentially what was happening is at Vectorize, we were building a lot of agents. So people would use us, like our sort of first product we built was all unstructured data processing. We would build out some of the structured search queries. We'd build out graph. We'd build out kind of all those data pipelines. And then we kept seeing that people were using those for like some type of agent. So for example, we have a customer called Grok. They just got acquired by NVIDIA. And they were ingesting a bunch of support data. And we realized, well, the support data is great for the support team, but product management could use that too. There's a gold mine in this support data where our product managers might want to look and say, what feature requests have come in that we should prioritize? Or, if a support person doesn't sort of like recognize that when a customer asks about a competitive feature, they may be thinking about churning. And so like we might want to alert the account team to something like that. And so we were building agents for all of these things and realizing all these problems with data retrieval that we needed to solve. We ended up solving it in what we thought was a really interesting way. And then we published out research and benchmarks that show kind of the performance of that. And I think I heard one question when I was saying all that.
Yeah, we got a few questions. Let me scroll up. First one is more like a comment, but from Prad, one of the way to evaluate the RAG agent is RAGAS metric. From these metrics, you will know the programs. If you have any.
Did you say, was that RAGAS was the?
Yeah, RAGAS. Mm-hmm.
I mean, I heard, I hear less and less about RAGAS. I heard a bunch about RAGAS like 2 years ago. And then I really haven't heard much about that at all since then. I think it's the challenge you have when you need to evaluate these things is you have to evaluate two aspects in my mind. So you have to evaluate your retrieval system. How well am I able to get the retrieval that I want, the data that I want, the context, and then how well can the LLM actually handle what I give it? And the problem that I see with a lot of these sort of evaluation frameworks is that they will tell you the net output, and they don't really pinpoint exactly what you need to do to solve that. Is that a retrieval problem? Is that an LLM problem? And so I mean, I suppose it's better than nothing. And I don't have anything against RAGAS. I've used it in the past, but it's been a while. I mean, I found it was kind of LLM intensive, to say the least. But if you find value in it, yeah, go for it. I mean, for sure.
Thank you. Another question is from Mus. How about using indexes like in Yama index?
Sure. I would say that you could use. I'm less familiar with Llama Index and what they've been up to recently, but I would say just in general, like your search strategies are going to need, to be thought through, I would say. And again, I think the main point here is like less about how precisely, like I'm not trying to give necessarily prescriptive guidance on exactly like what to use there, because I don't think there's a one size fits all. I think depending on your use case, you're going to have like some places where you're going to want PG vector, where I can build a search index on top of a structured representation that I can do joins across tables. And sometimes I don't really need that. I just need to be able to narrow down a set of documents and pull that back, in which case something like Quadrant with metadata filtering could be just fine for you, or Elasticsearch with their EQL or their advanced querying capabilities could be a good fit there too. I'd say the more simple cases that you have that are just sort of plain vanilla vector search, you can get away with like a Pinecone or a Quadrant. And then as you get more advanced, you kind of go into Elastic. And then as you get into the structured, you start getting into like more of the graph and the PG vector type type solutions that are going to be the better fit for you there.
Okay, the third question is from Prasad. How does people measure and evaluate the success criteria and accuracy percentages for I don't know what is about for task when evaluating using AI for document data extract and import into database?
So I think that question is, if I heard you correctly, it's mostly about the accuracy of an extractor. Like, so I'm taking it like more of like a vision model question and like a complex layout question. There are some benchmarks that have come out around that recently that I haven't looked into very closely. I've seen like some bake-offs that have taken place. The thing is, like, you're going to have the nuances of your data. So like if you're a legal firm and you're dealing with legal has some of the worst documents I've ever seen. They're often like faxed over and then scanned, and they'll have almost like fax machine jams that are in there. You'll have, all sorts of evidence that gets submitted, handwriting. So you'll have one set of challenges if you're dealing with that kind of data versus if you're dealing with things that are, more catalog data that has really complex formatting, or you're looking at like user manuals that have a lot of tables, and the tables span multiple pages, and you want to be able to retain the header, and you want to keep all the tables together, and you start getting into semantic chunking once you're done, right? So all of those things are really hard to quantify in a single benchmark. Now you can at least usually get down to some sort of category level scores to understand the strengths and weaknesses of each one, right? So like if you have Llama Parse is pretty good at tables, like for example, but I've seen them be not as good at like complex layouts, and I won't pick on some others that are out there that I think are just way overrated and poor around the just generally speaking. But I think the best way to do it is to take the documents that you have that you're going to be using that are representative, and just spend half a day and drop them into the models that you're going to be using, because I don't think you really want to just trust a benchmark, like an abstract theoretical benchmark for the things that you're going to be using and counting on. So non-answer, apologies for that, but that's the truth. I don't think there's a way around it. So let me move on to Sako, and then we'll kind of come back if there's time.
Sounds good.
So okay, so check this out. This is actually really cool. This is kind of the meat of the presentation here, which is on an open source memory system that was one of the co-creators of, called Hindsight. And it's a different type of memory system. I kind of talked about that flow we went through to build agents, and we approached this problem by looking at other memory systems that are out there. And what I found is that most memory systems that are available today focus on this idea of conversation history. And I just want to be able to remember what we talked about in past sessions. And essentially, it's RAG applied to the conversation history. And I don't think that's going to cut it. I don't think it's a good strategic fit for anyone that's trying to build out transformational AI for their organization. So we set out and said, well, our agents make mistakes. What they don't do is actually learn from those mistakes today. So how do we build a different kind of memory system that will be able to do all those traditional tasks, but can actually learn over time, so that my agent gets better? I get out of that endless loop of my agent messed up, let me go update the prompt. My agent messed up, let me go update the prompt. And instead, let's just have the agent memory system handle that for us, so our agents just get smarter and smarter. And so I'll talk about how we do that, and I'll show you a demo of that in action. So let's start off by thinking about, how do we as humans, right? How do we form memories? How do we learn, right? So we don't read a book and then remember every single line from that book. We usually have some key points that stick with us. And then it's over the course of, time that we get exposed to these, these thoughts, these topics, these pieces of information, and we think more deeply about it. And that's how we start to form an understanding. And we usually put that into some sort of mental model, right? We start to understand, like, the more complex systems that we're dealing with by understanding like, oh, system A talks to system B, and here's my organizational structure that I'm working with. And we start to have those models, and we only get those models from time and knowledge and reflecting on that. And so as new knowledge comes in, we're always building on top of the base that we already created. So when we need to recall memories, sometimes it's very simple, right? If you ask me, hey, Chris, what time does your daughter's school start in the morning? I'd say, oh, it starts at 8 o'clock. And it's a very easy, very simple memory to kind of pull back. Versus if you ask me like a question like, is this meeting tomorrow important? Well, now I need to understand a few more things before I can even answer that. I need to understand, who's the meeting with, what are we going to be talking about, and then what do I consider important? If it's a meeting to go get new shoes, like I could probably skip that if I need to. But if it's a meeting to talk to an investor about are they going to give us a bunch of money to build a company, that's a really important meeting. I better make sure that that's something I'm on time for. And so a memory system needs to understand these relationships as well. We start to get into things like causal relationships. We start to think about time series. So if you say, hey, why did you move to Colorado? I'd say, well, I was at Google. I moved into product management, and they said you had to be close to the engineers. And I had the choice between Colorado and California, and I picked Colorado. And so we have this kind of time series of events that happen, and that's how we are able to answer these why questions. And then we have things that are more opinion-based, right? So there's no one right answer, but depending on our agent has to think about it from its mission standpoint. So how should we spend our marketing budget? If I'm a finance person, I might say, well, like, how do we minimize that marketing budget? Versus if I'm a CMO, I'm going to think, like, how can I get as much as I can? I want to do as much marketing as I can, and it's going to help us grow. So we had to think about all of these things, and then as I kind of went through those, right, you can imagine if we were, if our brains were represented as a physical data structures, some of those things are basic search, right? These are things like, I'm going to do semantic or keyword search. Some of these things I need to understand, like who's my meeting with? What are we talking about? I need like a graph structure. And then some things like the why questions, I need to have more of like a time series. I need to understand the causal relationships between all of these things. And so in Hindsight, this is essentially what we built, where our agents don't just work off of the conversation history and the chats that are happening. They actually go off both the chat and the task automation. And so in those cases where we were talking before about like inconsistency, as the tasks are attempted to be completed, these go into what we call mental models, so that the agent can get smarter at understanding the user's intent, its mission, what it tried, what it worked, what didn't work, and ultimately how to solve that task better the next time it tries, until ultimately it gets consistent and very accurate at that. And then when we need to do recall, depending on the type of query that we're working with, it may be a query that's best structured for time series. It might be a query that's best served by structured data or by search data. And so we essentially pull out these different representations, and they all go into our memory store. And I'll show you an example coming up. A lot of the other agent memory systems that you'll see out there are basically just RAG systems. They're just conversation history and searching over that conversation history. And I don't think that's going to be enough for us if you're really trying to build transformational AI change into your company. So we think about memory from a few different perspectives. So, back on here, right, when the agent is looking at things, we wanted to separate out these ideas between the objective world facts, what do we know, what have we learned as we go, kind of the individual pieces of information, versus the agent experience, because our agent will naturally have its own experiences as it operates. And we wanted to bring these two things together into this world of observations, because we'll have things that conflict, we'll have things that change over time. And so we essentially wanted to consolidate down these memories. You can think of this as like a deduplicated version of our raw memories that have been that have any conflicts resolved, right? So if I said 2 days ago, oh, I'm going to go to Italy, and then yesterday I said, oh, I'm not going to go to Italy, it's too expensive. Now I have to resolve this, like Chris is going to Italy, Chris is not going to Italy. And the observations allows you to create a better memory here that says, oh, Chris actually wants to go to Italy, but it's too expensive, right? And that's something that's very unique to how we process memories in Hindsight. And then, as you can imagine, doing all those processing of memories can be like on the fly, can be slow. And so what we do is we allow you to create these mental models, which are essentially key value lookup. So you're able to get all of the processing benefits that you get from taking all those raw memories and turning them into something more consolidated, but you're able to get those in a snapshot form where they can be looked up really, really quick. You can also, of course, go directly and pull the raw memories down. Now, you don't know at the offset if a particular query is going to be best suited for a search or for graph or for time series. So what we end up doing is we have parallel retrievals. So we will have our 4 retrieval strategies go out and fetch whatever it finds. And then what we do is we pull those back. We use a cross-encoder re-ranking model to score those by relevance, so that we'll get back now the most relevant things sort of at the top of the list, the least relevant at the bottom. And then you can set a token limit. So how many tokens do you want to pass to the LLM? Will get you the most relevant in tokens. And ultimately, you'll get back what you need here. And all of that sounds like fairly complex, but we've boiled it down to 3 really easy operations. So you basically have retain, which is how do I get memories in, recall, which is how do I get memories out, and then reflect, which is how do I understand sort of the connections between all these memories in a more synthesized way. And it turns out that this is actually like a phenomenal way of building a memory system. Hindsight is our open source project that you can go play around with. It's MIT licensed, and it's the most accurate memory system that's ever been tested according to benchmarks. And it does things that no other memory system does. So if you're looking and saying, hey, I just want conversation history, use Hindsight. It's going to be incredibly accurate. It's going to work for you really well. And then it's going to do some things on agent learning that you're not going to find anywhere else. And this is a good time to maybe pause for a question, and then I'll jump into the demo and show you how the agent learning piece works.
Sure. I think the first question is, I think you already touched upon, but does this use reinforcement learning?
Not in the traditional reinforcement learning sense. That's maybe a good transition. I'll just kind of go in and show you sort of how this works. So, here what I have is I have this demo agent, right? So this is a demo package delivery agent. The idea is I've got this little guy down here, and he's going to get a package. He has to deliver the package, and I have given him no memory. So we're starting off completely fresh here. There's nothing. This is Hindsight, right? So Hindsight, these are the things I was just mentioning. We have world facts. We have our agent experiences, observations, and mental models. And right now, all of these are empty, right? I just have kind of a placeholder here for like the building layout for our agent. And so what happens is when we, let's take our agent here, and let's give the agent a random delivery. And so he's going to try to figure out that how do I deliver a package to Robert Blake and archives. And right now the agent has there's no prompt here beyond just you are delivery agent and you have these tools. And so the agent is essentially just using tool calls that you can see down here that it's been using. So it's checking its location, it's checking the list, it's going up, it can move left, move right. And then as it does, it's seeing if the person it's trying to deliver to is actually in that place that we're looking at. And so for this first attempt, it has no idea. It's just kind of randomly trying to figure this out. Now, back over here in Hindsight, we've started to form, kind of the initial memories from the system. So, we were trying to deliver to Robert Blake. We eventually did. The agent has experiences of, delivering that package. And, over time, we'll start to form out these more complex observations. And these will be, again, you can view these as a time series, as a graph, as a structured data, right? So it gives you kind of the best of all worlds here from a retrieval perspective. Now, one thing that I'll mention is that our agents will have different missions, right? So this is a pretty simple, I mentioned that our agent only knows kind of these things here, right? Just knows that this is basically the system prompt. That's all we gave it. And we have this idea of a disposition, right? So depending on the agent that you're building, you might want to have the agent sort of interpret data a little bit differently. And that's this, what we call a bank profile. So in Hindsight, we have this idea of a bank, which is like a memory bank. And then the profile is how we process the individual incoming raw memories based on the mission of the agent. So if you had something like, a bill collecting agent, right, you might want the skepticism pretty high, because if somebody says like, oh, I'm going to pay you Friday, but you haven't paid me, for like you're 6 months behind on your payments, like I'm going to be a little skeptical of that. And if I have something like a legal contract reviewer, I probably want my literalism really high, because I want you to really interpret this language, not with no wiggle room. I want to know exactly how it could be interpreted. And so we let you customize the agent behavior here, and then all the memories that you're processing get floated in. And as we go, right, this is what I was saying, we kind of have our raw model, our raw memories that come through. And then as our agent gets more experiences, we start to build out these mental models. And so these are like really fast snapshots, because I know my agent on a regular basis is always going to need to know the building layouts, the employees that it's going to be delivering to. And so as we do, as we, deliver more packages to people, we're going to continue to refine that understanding. And as we have more tool calls and the agent has more experiences, all of those start to go into creating that more complete mental model. And I think there was a question.
Mas was asking, how about if you're not dealing conversation history, but context data or latest data where we structure and vectorize data, should we still use RAG?
Should we? Let's come back. Let's come back. If you have questions on the demo, ask them now. Otherwise, I'll kind of take the more general questions at the end.
Yeah.
About things, if that works. So, so as we do this, as our agent, goes and it, learns, more, and we start building out those mental models, as we, oops, I clicked on the wrong one. I don't want to do five packages here. If I do, let's do like this one here. Right. So I think we delivered to this guy before. I think that's the person we delivered to. As our agent gets more experiences here, what's going to happen is it's going to get better at its job. Right. So like before that first time we tried to deliver this person, our agent was like going all the way up here. It was trying different offices. It had no idea who Robert Blake was or where he worked. And now what's happening is that we have, it went from the starting point directly to the office, delivered the package in very few steps. And that's because our mental model has evolved, and as it evolved, we started to understand, who's Robert Blake, here he is, here's where he works. Here is the building layout, so you can find archives on floor 2. And then here's what I've learned about the delivery path. And so the same way that we're doing, we're building out these mental models for our package delivery agent, the same technique applies really well to other cases that you might be working with if you're, customer service, and you need to understand, like, how do we resolve issues? What's the right way you want your agent to behave? One of the things we can actually do is we can take transcripts from things like, if you have transcripts from, Ring Central, for example, you use that for your call center, and you want to take those and you want to ingest those and kind of build out the mental models for your customer service agent. Those are ways that we can, you usually want to start off your agent by saying, hey, here's a completely blank slate. I'm gonna have you perform terribly for the first couple of weeks, but then I want you to improve over time. We have sort of this ability to pre-train the model or pre-train the agent here as well. So that when you go to turn that on for those first experiences, it already has these mental models populated, and we can use that from some historical data. And so back to the question, there is this idea of documents on here. So when you integrate with Hindsight, you have a few options. So one of the options that you have is that you can just use the LLM wrapper. So it supports over 100 LLMs. So if you're using OpenAI or Anthropic or Gemini, any of those, you're for sure fine. If you're using any of the like mainstream open source models, Quinn, you should be fine there as well. And so when you do that, it automatically will just kind of add memory to your system. So that we have a wrapper that sits there. It's 2 lines of code. You replace the call to your client. like here. You just replace this guy with the wrapper that we have, and then automatically that will start to take memories, push those into the system. It'll automatically retrieve memories based on the requests that are coming in. And this is like the set it and forget it kind of mode, where you don't have a lot of really specific ways that you want to process those memories. Now, if you do want to process memories in a more specific way, we also have a as you would imagine, we have an API. So we have like these three operations that you can call directly. And so this is where you want to set specific metadata. You want to recall, set metadata filters on your retrieval, for example. These are all things you can do here really easily. And then kind of getting to the question about the, if I have documents and I'm kind of using RAG, this is another thing where you can actually just use your memory system as, either as like a dedicated memory bank for those, or just alongside the rest of your memories. You can actually just push those directly in. And so this kind of gives you now a single unified agent memory solution where you've got your semantic memory, which is like all of your kind of your bookshelf stuff, right? So like all the documents that you would process, along with all of the episodic memory. So all the examples, things that you talk to users about, the conversation histories, the agent experiences, the lessons learned along the way. And then you can use all of that to now consolidate a more accurate mental model that your agent can just have this immediate lookup for. And so, all that comes together in, I think, a pretty, pretty powerful way that I don't see any other memory systems, working to be able to support agent learning in this way. So that was my answer both to that previous question we had, as well as a little bit of additional context. Do we have any other questions, Asako?
Yes, we have a bunch. Maybe you can take a look and pick.
I actually don't see. I don't know where you see those. I see. Yeah, I don't have access to them.
Oh, isn't there a bubble on the right bottom corner?
There is, but it just says chat with everyone.
Oh, you can just click on it.
No, I did. It says no chat messages yet.
Oh, that's.
So I don't know if I need to be in like the host tools. This is like a very different view of Google Meet than I've ever seen. So I'm.
Okay. Then let me read some latest ones. In a real-world environment, how do you determine if something is accurate or not? Does it require users to thumb up or something?
Yeah, is there like an example that they have that they're thinking of?
Like how do you determine if something is accurate or not? Like, is it like a human in the loop, like require users to thumbs up?
Yeah, put a follow-up on there in terms of like what you're like. Give me a concrete example of that, because like something is a little too broad, I think, in this context of will it be accurate in terms of like, was it in the source document? Yes, for sure it will be accurate if it was in the source document. Is it accurate in the sense of this is something that we talked about in the in a previous conversation history? Like, yes, that's definitely going to be accurate. Did the user say something incorrect? Like, that's now you kind of need to rely on your LLM to for some interpretation on that, I think. Now what we will do is we'll do like some conflict resolution for you, right? So if we've heard like one thing and we've gotten another, like our conflict resolution will kick in when we do that consolidation for the memory, and then that can help there. But if somebody's just giving us like giving your agent like just complete wrong information, the memory system it's a memory system, right? It's like, hey, I remember being told this. I remember we talked about this. It doesn't make any promises that like what it remembers and what the user told it is correct, right? Go back to that bill, like that bill collection agent, right? It's like, hey, this person told me, oh, my uncle's in the hospital and I don't have any money right now. It's like, they told us that. I don't know if that's true or not, right? So we're sort of at the mercy of the information that we have.
Cool.
If you have a follow-up, ask it. If I'm kind of missing if you have a specific example, we can discuss it.
Cool. Okay, another question is from Caruth. How do you decide what to add into memory based on the failure. I have the same issue you're discussing, a large prompt, more context, a lot of topic.
Yeah.
Yeah. Do you
Yeah.
have
So like basically what happens here is that any of the tool calls, I think you can push those directly in. And then what happens is we treat that kind of raw, like in this case, like a delivery, for example, as a document. So we see all the things that it did. And then what will happen is that as we reflect back on this, right? So like one of the mental models that we had here was this optimal delivery path, right? So part of what we want to do there is we want the agent to realize where it didn't have an optimal delivery path, where it was like, and you'll see this with, we talked about kind of the agents getting stuck before, right? So you'll see this all the time where, and I've seen it with this demo too, where it's like the agent will start here, it'll like go up, it'll go back down, it'll go back up, it'll check again, like it's checked stuff that it's already checked. And so part of what that mental model of reflection cycle does is it takes the raw history and it gives the LLM a chance to find out what it's doing wrong, right? It's like your optimal path is not to go recheck the same office over and over, as obvious as that sounds. And so as you're building out that kind of log of your task attempts, and you're building your mental models to support that, what should happen is that mental model starts to look back, understand what it did wrong, and then improve the instructions based on the behavior that it's seen in the past, the agent or the LLM, kind of get caught up on. And so in doing that, you get out of that business of, now I'm going to go refine my prompt and I've got to go tweak this again. And instead what happens is I just get a better mental model. The agent can pull that down, and now I'm going to hand it off to the LLM, and it just has built-in instructions that get self-improving instructions as the agent gets more experiences.
Great. Do you have other slides? We have more questions, but I wanted to make sure that we can.
I'll pull this up, but I think we kind of hit the main thing. My favor here to all of you, Hindsight, we're trying to get the community built up. If you would all be so kind and leave us a star out on GitHub, I would really, really appreciate it. If you get a chance to try it, I'd love to hear what you think about it. And then I'm happy to, spend the next 10 minutes or so on additional questions if there are.
Thank you. Okay, another question from Neil. How would you define the difference between memory versus context engineering?
Between context engineering?
Mm-hmm.
Well, that is a great, who asked that question?
Neil?
It's a great question, Neil. And my definition of a great question is one that I have like ready-made content to answer. So here's how I kind of view the difference between these things. So to me, I've got my LLM as my context window, and that context window is going to contain, a few things in it. It's going to have my messages array that I've been building out like throughout the, either task automation or the conversation. It's got my system prompt. It's got my tool array. And my goal with context engineering is how can I like the perfect context engineering is I give the LLM exactly what it needs to respond accurately and in the way that I want to the specific request that I have at it. And so the way that we perform context engineering now is a combination of these other things, right? So it's a combination of I need to have some way of getting my context. Right. I know I said RAG is dead, but let me sort of like give a little bit nuanced answer on that RAG is dead topic, because RAG to me means two things, right? And they're sort of like when people say the word, when they use the term RAG, almost always what I find they're talking about is that I've got a vector database and I'm just doing semantic search over it, versus what I think is maybe like a more like literal interpretation of these words, which I think will be around forever, which is my LLM needs additional context. I need some way to retrieve that context. Like even agent memory from that sense is RAG in the most literal sense, right? Where it's like, I need to retrieve things to augment my generation. I don't think that pattern goes away, but I think the idea that like, I just have a vector database that I can query, that goes away. So let me just sort of make that clear. So that whole process of saying, how do I fill up my messages array, my tool prompt here, with the right context, whether that's context from short-term memory, my working memory, or from like episodic memory or semantic, that whole process to me is at the crux of context engineering. And that's kind of what we're trying to do here, right? So like this is why we have this like token limit, is to say, well, depending on the nature of the request that we have, the right way to pull that context back might be through semantic search may give me the best results, like keyword search may give me the best results. I might need to walk a graph, I might need to do time series. And the idea here is to say, how do we build, if you say, I don't want you to give me back more than 5,000 tokens. How do we make sure that 5,000 tokens in sort of this like context engineering sense is the best 5,000 tokens, is what our goal is with the memory system. And so this is why when I kind of look across all these and say, well, I've got semantic memory, episodic memory, mental models. To me, the idea behind the memory system is figuring out how do I get you the most relevant, optimized set of tokens to put into that context window to get the behavior that you want. And so hopefully that makes sense. That's kind of how I view these things as interrelated here.
Thank you. A question from Ming Hui. How weights are given to events on time series?
I'm sorry, could you say that again?
How weights are given to events on time series?
How much weight are we giving to it?
How weights are given to events?
Yeah, so it will all come down to that cross encoder, like the cross encoder output that we have there. So like if the best things that we get back are going to be from the time series, if you ask a why question and we need to get back, we need to get back sort of a understanding of an understanding of like the series of events that happened, we'll weight those more heavily. And one of the things, if you kind of dig into that benchmark that I showed, so this is kind of the benchmark, the long memory eval. We publish out all the results. There's a place for you to reproduce it, but you can actually go into like the temporal reasoning category, and you'll see here, like if you want to see like the sample questions that get asked there, you'll see both like the events and how we pulled those back, as well as like the reasoning and the raw memories that get returned, and how those all come back to the model. So they get weighted based on relevance is kind of the short answer. And then if you want to go a little bit deeper, you can check out that, it's on the GitHub repo. There's a link to it. You can check out the benchmark results and get a feel for how it works with an actual data set.
Thank you. Another question is from Prashant. Can you please talk about the mental models? Do you give the LLM the choice of creating a new mental model, or all the mental models kind of predetermined and LLM picks and creates one from them?
Yeah, it's both. So we kind of have this idea of like what we call a pinned mental model, which are the ones that you want to always update. So like in our delivery agent, there are certain things that we always want that agent to be aware of and have the most up-to-date information. So like the building layout, the employees, the delivery paths. You can open that up, and you can have your agent decide, I say agent decide, right? But there's basically a process that will decide, like, do we, is there a set of tasks that we're getting, or a set of inputs that I'm getting where I need to create like a new mental model? And, that will, for example, like in personalized, chat sessions, for example, you may want, as a new user comes in, to, dynamically create one. You can either do that with an ID, you can do that with, there's metadata, or you can, give it a little bit more autonomy, I would say, in terms of how it develops those models.
Okay. Another person had a similar question. Can this memory be personalized in some way, different mental models for different users?
Yeah, absolutely. And in fact, that's one of the things, like when you go, they also cover that in this this long mem eval benchmark. Like one of these is the single session preference. And then there's also this multi-session. So like multi-session is like hopping, back and forth for a user across multiple sessions. And then single session preference is really focusing on questions about the user's preferences. So those are kind of key requirements that we were looking at when we were kind of developing and testing the overall efficacy of the solution. Yeah, we got time for maybe like one more.
Yeah. Okay. Question from Jim. In an agent memory system where agents can write and reflect on long-term state, memory poisoning feels potentially catastrophic. Poison entries can propagate into summaries, beliefs, then drive tool calls and business action. How does your system currently defend against this? And if you later discover that a subset of memory was malicious, can you actually roll back all derived beliefs?
Yeah, so essentially, we have kind of a hierarchical memory system here. So and it's built to do conflict detection when we find it, and then conflict resolution to what's the word I'm looking for? To kind of rationalize the different pieces of information. So you always have the raw memories. So like the raw memories are in the system at all times, and then our observation network is built to have the consolidated view. So that's where you start to get into not just summarization. I think summarization is kind of the not an entirely accurate way to describe it, because it's not meant to be lossy. It's meant to create the observation network where it deduplicates things that it finds, so you're not pulling back in that token budget that you have. Like if your agent's done the same task 10 times, right? We don't want to pull back like just the same duplicate information. We want to consolidate that down. And if we start to find the places where there are conflicts between those, we want to resolve those in a way that is accurate and reflects the nuances, I would say, of the data. And then the mental models are meant to be the snapshot. So those could be a bit on the lossy side, because they're meant to be like your snapshot that's going to come back and boil down like, okay, I've got all these memories. How do I make sense of that? Well, instead of trying to do that on the fly, we have these views which are very much in line with your agent's mission. And then based on your agent mission, your disposition, and the mental model, we're going to take that and we're going to try to give you the snapshot to say, here's exactly what you need. And so what that does for you is it says, well, now when I have something that's in a mental model, I've got this, I'll say single digit, but with network like latency could be more like double digit, right? Lookup latency, right? So I can have this really, really fast understanding of a whole bunch of memories at once. And I will do that for the things that are most important for my agent, so that they can have that understanding and develop and evolve it over time. So I think we're like right at time. Thanks everybody. Great questions, and appreciate you all hanging out until the end.